Hi, good morning. My name's Chun Qing Lee, aka Lee. I'm the founder of KREODx companies. It consists of an award-winning architectural practice and the software KREODx startup, and and also a small construction company dedicated to modern method construction. Thank you. So yes, I'm the founder of KREODx companies. I'd like to focus on KREODx today, which is the technology AEC fintech startup, and we've been building many stuff we call ourselves the digital master builder, not just an architect, a software developer, but also we built. And KREODx was formed in 2012, and my background is, the technology, parametric design, digital fabrication, which I believe, you will play the most important role in the AEC industry. And also we're focusing on the design for manufacturing assembly, which is a beyond BIM 2.0. This is the very first project we designed as a designer. Apart from structural engineer, I was everyone else, a project manager, principal contractor. So this was kind of a burning desire to design and build beautiful buildings called architecture with a financial viability. So this is kind of when we design something, it's always a question, how much does your design cost, Mr. Architect? So we're here to solve that problem, as well as the problem actually, the design for manufacturing assembly modeling. And the digital twin we had, not just the geometry, there's a metadata and the G code in this instance, it drives robotic arms and the manufacturing ready information. And the entire process was paperless design, engineering, construction as well. But the only printed drawing we had in this case, we didn't have iPad back in 2012 for the London Olympics. So we printed assembly diagrams. And they also develop a work beyond this design, an interesting structure. We develop a workflow. How can we design and build something beautiful, financially viable? In the same time, we can create jobs for non-skilled workers, for the young people. So that was kind of initiative. As you can see, the bunch of, we call them sweaty students, including myself. We assembled this a complex structure. None of us had any construction experience whatsoever. So this is the power of digital twin. Before you build anything physically, you test in the digital environment, how you put things together. And this is inspired by the aerospace automotive industry. And we have a couple of team members from, Tesla, Lamborghini, and aerospace as well. And yeah, we won some design awards actually, the construction industry award on finalists. We sadly lost the shard. Nobody could beat shard that year. And many other awards as well. So this is our software, and then we did a test again. We start developing the software with the Dassault systems initially, CATIA, which is being used in the aerospace defense industry. And as a software, it's too expensive, like 30 grand a year, and it's not affordable for many architects, engineers. So I decided to, and the Siemens approached me and they said, all the software actually developed on the Siemens Parasolid kernel, including like Bentley system, ANSYS, many other powerful engineering software. So yeah, that's a new journey started from there a year and a half ago. And this is the case study where we involved. I call myself a digital master builder. So we build everything digitally. Manufacturing ready information is a digital twin. So beyond the digital twin, the display behind is what you see, the steel frame. It actually automates and generates manufacturing code. So when we tender the job, we're no longer using the traditional, the QS method, square meter, construction price per square meter. We'll actually give this code to all the manufacturers to give us a quotation. And also the system we developed initially with Dassault is, with a few clicks, it generates and automates the construction information. 90% is ready. And then in the same time, we're building a marketplace linked to the supply chain. So you can get live costing very soon. It's coming soon. And so just make the whole process very, very lean, and also providing transparency and more certainty towards design and development and the delivery. And you can see with just a simple click, a receptionist can do that. My 7-year-old kid can do that. It's just, very basic concept design intent. You click the building systems, it generates, automates the bill of materials, and following that, the costing. So we're building more libraries for our users. So, so we need to, everything we've seen. And also another case study, we did a house in Surrey, the DFMA approach, design for manufacturing assembly. With a few clicks, it generates automated, the Kingspan cladding systems. And we prove the concept. We give the elevation drawings from the beginning. They price 186,000 pounds. We give the bill of materials, all the shop drawings, the digital twin, and then they price 142,000, 44,000 pounds cheaper. And all these shop drawings were automated and generated, ready for manufacturing. Just a few clicks. This is what we focus on, building a library so the users can focus on the design, and delivery rather than trying to figure out what Kingspan did. The notion is to stop preventing people reinventing the wheels, and they can focus on what they do, what they're really good at, and also develop digital twin assembly sequencing tools as well. So the idea is not the big brother, watching people, what have you done today? The idea is if you build faster, we price a package. This is £100,000 package to assemble this. In theory, Lee and Paul can assemble 3 panels a day. If you did 6, we'll double pay you. So the notion is, if you work faster, we'll pay you more. We can see based on the digital twin, and we break down all the assembly sequencing, etc. So you don't need to manage people, with people more self-sufficient, because there's an incentive for people to work faster and quicker because they could get more money. So it could be useful for the public sector though. And also this one, we also did digital twin. We were the KREOD was the lead architects, the delivery architects. We did the detailed design using KREOD software, and also we were the principal contractor. And this case study is, we did the trial pit, the old school method, because we had the piling right against the retaining wall next door. They had a secret basement built many moons ago, and we don't know where they were. So, and I thought, let's do a quick scan, see where they are exactly. It turns out that corner there, the retaining the internal wall to the boundary line, sent to the boundary fence, 172 mil. And they realized, they're retaining wall somewhere. It's on our side, somewhere in the ground. So I had to inform the client and change the design. We had the piles right against that wall. I had redesigned the whole thing. So yeah, also, it's not the digital twin. It's not just to make something more efficiency, but more importantly, keep me out of trouble. If I just did the piles, without this information, I wouldn't be here by now. So yeah, definitely bankruptcy mistake, which is not really my fault. I can't see through the ground, can I? But leveraging technology, 3D scan, digital twins, yeah, it kept me out of trouble big times. And also we did a 3D, and also we left Dassault Systems, started our own software. The biggest concern is that the software must be able to handle a large assembly file, because it's 100% detail modeling. It's a real digital twin, not the Revit, the BIM software representation. So it's more than just the geometry, but also the manufacturing information, and beyond that, operation maintenance. That's what we're focusing on. And also we're now building templating, like according to the new building regs, the new Building Safety Act, especially on the fire, say fire penetration. We templating, capture knowledge, templating all the system, and you can just automate it. So you will work rather than you trying to figure out how does a fire penetration works, who's going to sign them off, etc. So this is what we're working on at the moment. Should be fully automated in the very near future. And once you do the assembly, construction, just validate it on site. This is the design, all the build-up details, and the actual construction, take pictures, a 3D scan, and validate, approve it. So these are the kind of things we've been working on, down to bolts and nuts. It's quite important for design, engineering, costing, operation during the construction, logistic plan. When do we need what? How much did it cost? When you issue, and also, yeah, this one. So we test the Autodesk Revit. I've got a very powerful £20,000 workstation with me, and I installed the Revit. It could barely rotate this model from Revit software, and we export it. We played our software. Yeah, it flies. So it's quite good. Very confident now we can handle large assembly files. It's kind of this is very exciting times. That and also we're working on some retrofit project as a lead architects. the digital principal contractor using the KREODx software, and also the physical principal contractor. We're going to build this as well. So lots of retrofit project we're doing, like in Mayfair, South Chelsea, Bloomsbury, and I'll like to share more information. I need to get the clients, confirmation on
this. Well, and
this,
also I'm afraid we're coming up for time as well. So is this the end?
This is the end, pretty much. Yeah. So other creative projects as well we're working on, and and also we'll share more about this project later as well. The Browns Hotel we're doing in Mayfair is due to complete. We'll finish this week. So the fit out carpentry work, cutting list, all automating generators, and the testing all this, the hinges, tactus hinges, how they work. We scan the existing building because there's a 5-star hotel. So aerospace accuracy, the tolerance, the settings, because it's a very old building, So yeah, this kind of thing we do. And the software will be ready, the beta version will be ready by September. So this is how we integrate the software, the marketplace, ready for costing. And also we have another third pillar is the fintech, the payment systems. So we're solving the procurement. So it's just, one platform solving all problems. Yeah, build, don't talk. Thank you.
Does or could your system track the use of building materials across their life cycle for the purpose of reuse as part of a circular economy?
Yes, we're building that system, and then obviously, as you can see, the software actually generates all the cutting lists, build materials and quantity. So yes, it does. And also we're building this, the library next to all the supply chain. You can track and trace and track where they come from. And also we ask all the suppliers to put the carbon footprint data as well. So you can see that not just the costing, how much, what they are, how much they cost, but also the relevant information and the metadata. And also building on the top of that, we're building interface configurator between different systems, how they work together as well. So this is the biggest thing, when the designer put something together, they don't work. And then when they realize on site, it's just too late.
And now back to you, Chun. So you said that your generated designs save 140k. How do you verify to ensure that your design isn't missing crucial pieces?
Yeah, we template everything, all the building systems. That's what we're building. So if it doesn't work, it doesn't generate. And the example of the cladding system saving 44,000 because you have the exact quantity down to bolts and nuts, the level detail, a real digital twin. Yes, so we're building the building systems. So our user can just automate, generate, because you don't know what think about it. In the construction industry, each industry, everything's designed and tested, built by other, manufacturing suppliers. As an architect, engineer, you don't want them to reinvent the wheels. This is a system like to use Suco Windows facade system or Kingspan, whatever they are. You should just be able to click and generate a result very quickly, understand the architectural aesthetics, the cost implications, and also on the top of that, carbon footprint, X, Y, Z, say, well, like H steel frames, very high carbon footprint. Can we try, CLT or other method of construction? That's it, yeah.